Yeah, good morning, all. So, today we are going to see regarding power quality, and initially, we are going to start with the introduction to the power quality. Now, right now, the advanced topics in electrical engineering are regarding introduction to power quality. What is the power quality, the meaning of power quality, and why this power quality is essential as far as the electrical engineering is concerned. So in first slide, so that we are going to discuss what is the definition of power quality. Now, if you are going to see by definition, it is defined as either voltage quality or the current quality. Now see, at the output of any equipment, otherwise whatever the input that you are giving to the equipment, so input that should be a pure sinusoidal waveform. And if you want to give a pure sinusoidal waveform, or if you want to take a pure sinusoidal waveform, then uh, you will have a good power quality. But sometimes, because of some reason, if you are going to connect a load more than the expected limits, otherwise what you can say is there are something problem that you will get in the sinusoidal waveform. So in that case, so we can say that there are a power quality issue. Now, second thing that we are going to discuss here, that is, it is aimed at maintaining the system's voltage current as pure sinusoidal width per unit magnitude at per unit frequency, and the phase shift of 120 degree between the adjacent phases in three-phase system of the voltages. So simply, so ideally what we requires, if the three-phase system is there, then there should be a three phase of a 120 degree apart. So that kind of system or that kind of sinusoidal waveform if you are getting, then you are saying that your power quality is good. But another term is there that we can say, the term power quality aims at maintaining unity power factor always in the system. Now ideally that is not possible, so that is what the ideal case, so to maintain unity power factor at a system. So some, as per the load connected to the system, there may be a chances of what you can say, either inductive load is there, otherwise capacitive load is there. So depending upon that, we'll get a lagging power factor or leading power factor. So this is what you can say, the definition. So if simply in short, if you want to say regarding a power quality, simply that is a pure sinusoidal waveform. Now, now, so what are the points that we need to cover in a power quality that again we are going to discuss here. So introduction and importance of power quality. Now what are the symptoms of poor power quality? So we are going to use the word that is poor power quality. That means that is not good power quality that we can say. So various power quality issues such as transients, short duration voltage variations, long duration voltage variations, voltage imbalance, voltage fluctuations, voltage flicker, and waveform distortion. So all these are the power quality issues. So in this chapter, we are going to discuss all these issues. Now next thing that is very important, that is relevant of power quality standards such as IEEE 1159 2009 and IEEE 519 2014. So again, these standards regarding the power quality that we need to study, because so if you want to visit any industry and if you want to go for the energy audit, so in that case we should know about the power quality standards, and these quality standards are given in the section that is IEEE 1159 and IEEE 519. Now here we are going to discuss, so IEEE 1159 is for what purpose and 519 is for what purpose, so that we will discuss later on. Now the fourth part that we are going to discuss, that is grounding and power quality issues. So these parts that we are going to cover in the chapter number 1. Now coming to the next point, that is importance of power quality. So before going to study the power quality, so what is the importance of that power quality that we need to check it out. So first one, that is increasing use of electronic devices. So as if you are going to think about the initially we are going to use the incandescent lamp. So these incandescent lamp, instead of that, we are going to shift towards the LED lamps, or what you can say LCD lamps, these different lamps that we are going to shift. So because of the invention of the semiconductor devices and electronics devices, so we are trying to move towards the LED lamps. The reason behind that is what? So for the same luminous, so we can go for a less number of wattages. That means we are going to save the energy level. So that's why, so as we are going to use the more electronic devices, there are chances so that you will get the power quality issues uh, in the voltage and current waveform. So that's why the power quality plays a vital role. So the increasing emphasis on overall power system efficiency. Again, because of this power quality, if the stability is not there, voltage stability is not there, if you are not getting pure sinusoidal waveform, if you are not getting a pure current waveform, if the current harmonics are there, if the short duration and long duration voltage variations are there, so in that case you will get what you can say, uh, there that hampers the power system efficiency. So that's why we need to look a good look in a deep as far as the power quality is concerned. Increase the awareness about the power quality issues. Okay. Right now the industries, the different industries are there where we are going to conduct energy audit processes. So if you are going for the energy audit, in that case, so we are giving suggestions as we are the electrical energy manager or energy auditors are there. So in that case we are going to introduce some different devices. So if you are going to introduce the different devices, there may be a chances of power quality issues. So that's why, so every industrialists are going to check these power quality issues. So more awareness is there. So that's why, so everyone is going to check that properly. The next thing, so interconnected in network increasing. So interconnection, that means a grid system that is now that is going to increases. So that's why the power quality that we need to check it out in a proper way. So many things are now productivity for all utility customers. So whatever the utility customers are there, again, so we are going to think about the long duration, or what you can say, durable equipment for different applications. So that's why, so when the power quality is a poor one, that means if the poor power quality is there, there may be a chances that the life of that particular electrical equipment, that may be hampers, that may be goes down. So that's why the power quality plays a vital role in the day-to-day life. So that's why, as we are the utility customer, we need to check it out in proper way, and we have to check it out whether you are getting a pure sinusoidal waveform of voltage and current. And if you are giving a pure quality power quality, then definitely the durability of the electrical equipment that is going to increase. And so if you are going to think about the efficiency is also going to increase in that case. Now next thing that we are going to discuss about the increase of interest in distributed generation. So if you are going to think about the distributed generation, so this distributed generation, so we are going to we are going to increase that distributed generations. Then the globalization of industries. So globalization of industry, that is what one of the factor. So all these factor that we need to study. So this is what so these points that we are going to discuss, that is regarding importance of power quality. Now here we are going to check it out the symptoms of poor power quality. Now, what are the different symptoms of poor power quality is there? So, first thing, if you are going to apply a poor power quality to any one of the system, there may be a chances of equipment failure at the same time of a day. See, if you are not having giving a proper voltage and proper current, or a pure sinusoidal voltage and current, then there may be a chances of low voltage or high voltage. So in short way, that we can say the voltage sag and voltage swell, and that kind of input if you are giving to the equipment, then definitely there may be a chances to fail that equipment. Second thing is what, if you are going to think about the, if the voltage swell is there, or what you can say more current is there, so in that case a circuit breaker trips without being overloaded. That may happens. Then equipment fails during a thunderstorm. So thunderstorm is there, there may be a chances of high voltage, that means lightning strokes. If that lightning stroke is there, then the voltage of that equipment that may be increases because of that lightning stroke, and the particular equipment that may damages or that fails. So automated system stops or restarts for no apparent reasons. See, if the automated system is there where we are going to use the relays or some automatic system is there, so where we are giving some threshold values of current and voltages. So if the poor power quality is there, so simply the best example of poor power quality is what? So higher voltage or low voltage. That may happens because of some reasons. So if that happens, then automated system starts and restarts that continuously without any reason. Suppose if the current that we are going to take a 10 volt 10 ampere, and for a fraction of second if it goes uh, 11 ampere, and again it is going to regain its position, but because of that reason you will get what you can say, you will get frequent operation fail of that particular automated system. So electronic system fail to operate on a frequent basis. So electronic system fail to operate on frequent basis. That means again there are some power quality issues such as voltage sag, voltage swell, harmonics, transients, and short duration voltage variation, long duration voltage variation. If all these power quality issues are there, then electronic system fails. So electronic system work in one location but not in another location. So these are the some symptoms of a poor power quality. Now here, so symptoms of poor power quality. So what will happen if you are going to give a poor power quality uh, to the any one of the equipments, or if the poor quality is provided by the Maharashtra State Electricity Board? In that case, what is going to happen? So first thing, electricity bill. So high demand charges that you will get. Second thing, power factor penalties. You will get a power factor penalties there. So ultimately electrical bill is going to increase. Okay, so all these points, that low power factor, again, so you will be penalized if the power factor is below the threshold value. So all these, that is to at the end, that is going to hamper the money of that particular utility customer. So if the poor power quality is given by the sources, the computer problems, sometimes the computer crashing that will be there, sometimes the computer locking up is there, sometimes what you will get, you will get a computer memory loss, sometimes the computer crashing. So all these problems regarding the computer that you will get. So office problem, if you are going to work in any offices, and if the poor power quality is there, then you will get a dropped telephone calls, erratic equipment operation, some noises that you will get, equipment running hot. Okay, if the load is not there on the motor, so still that motor uh, uh, at running condition it shows you hot. Then HVAC problem, that is heating, ventilation and air cooling problems that you will get. So sometimes you will get a motor failure, sometimes you will get a speed setting drifting, component failure. So all these symptoms that you are getting of a poor power quality. Then next point that we are going to discuss, that is the general problems. Now the general problems such as noise and stripping, then so see, if the poor power quality is then you will get some noise. Then circuit breaker failure or circuit board failure, many times the circuit breaker failure that you will get. So overheating of the transformer is there, overheating of the cable is there. That means because of no reason, if the harmonics are present in the system, or the input given to the particular transformer, where we are giving a poor power quality, or the harmonics are created, so in that case you will get a overheating of the transformer and cables, excessive neutral current that you will get, surge suppressors, UPS failure you will get, so power supply failure. So these all are the symptoms of the power quality issues. So if the power quality provided by the sources, if that is not as per the requirements and as per the standards, so definitely all these problems that you will get in your equipment at your utility system. So these are the symptoms of poor power quality. So that's why So we have to give a more focus on the power quality. Now we are going to see the power quality issues. So what are the different power quality issues are there? So transients, so impulse transients and oscillator transients. Now short duration voltage variations. In a short duration voltage variation, we are going to learn voltage sag, voltage swell and interruptions. In long duration voltage variation, we are going to think about the over voltages and under voltages, voltage imbalance that we are going to check, voltage fluctuations, voltage flicker and waveform distortion. So all these points are of a power quality issues. Again, we are going to see that is transients, that is impulse transients, oscillatory transients. In short duration voltage variations, we are going to learn that is voltage sag, voltage swell, interruption. Then long duration voltage variations such as over voltages, under voltages, voltage imbalance, voltage fluctuations, voltage flicker and waveform distortion. So all these are the power quality issues, and you want to check so how these power quality issues are going to affect your system and how it is going to converts or how it will get, that we are going to study in a next point. Now see, first we are going to discuss about the transients. So what is the meaning of transient, and what are the causes of transients, and what are the categories of the transients? So transient is the part of the change in a variable that disappears during the transitions from one steady state operating condition to another one. See, so simply if you are going to think about the power system, so whenever if the substation is there and if you are going to open the circuit by using the isolators, that means to break the circuit by using the isolator, so in that case you will get some transients. Okay, so there is a disturbance, or if you want to close or if you want to open the isolators, so in that case you will get some changes in the power system or some changes in the power system operation or a sinusoidal waveform, so that are called as the transients. So this is a kind of a short duration phenomenon, a very short duration up to a few cycle of voltage supply, so you will get a changes in the supply voltage, so that are called as the short duration voltage variations. Now, what are the causes of transients? Sudden switching on large load. If you are sudden switch to a large load, otherwise, if you are going to open the what you can say isolators, so in that case, there may be a chances of short duration voltage variations. That means you will get a voltage variation for a short duration. Now, what are the categories of these transients? So, impulsive transients and oscillatory transients. So as far as the two transients or two categories are concerned, so impulsive transients, that means, and oscillatory transients that we are going to discuss, these are the two categories of the transients. Now, so we will discuss here what is that impulsive transient. An impulsive transient is a sudden non-power frequency change in the steady state condition of the voltage and current, or both, that is unidirectional in the polarity. So impulsive transients are normally characterized by their rise and decay times. So for example, here 1.2 into 50 microseconds multiplied by 2000 volt. So impulsive transients. So peak value, that is 2000 volt, rise time is 1.2 microseconds and decay time is 25 microseconds. So all these are the impulsive transients. So this impulsive transients, so many times this impulsive transients that you will get when the lightning stroke happens. So lightning stroke is what one channel that you will get from cloud to ground, and because of that you will get a higher voltage, that is called as the impulsive transients in short, that we can say. Now what are the oscillatory transients? An oscillatory transient is a sudden non-power frequency change in the steady state condition of voltage and current, or both, that includes both positive and negative polarity values. An oscillatory transient consists of a voltage and current whose instantaneous, so value changes polarity rapidly. So classification: high frequency transients, medium frequency transients and low frequency transients, all these are called as the oscillatory transients. So here, so in this diagram that you will come to know that how the transients are there. So oscillatory transients current caused by back-to-back capacitor switching. The capacitor switching, that means charging and discharging of capacitor. So in that case you will get some waveform is like this, that is called as the oscillatory transients. So graph shows time in microseconds, so that's why the transients are for the few seconds or few microseconds that we can say. And so current, how the disturbances are there, that you are getting on the diagram. Now next point that we are going to discuss, that is short duration voltage variations according to IEC. Now here, International Electrification Commission, Commission category. So short duration voltage variation is the voltage dips and short interruptions. So each type of variation can be designed as instantaneous, momentary or temporary depending on its duration. Short duration voltage variations are caused by the fault conditions. Depending on the fault condition and the system conditions, the fault can be cause either temporary voltages or temporary voltage drops, that are called as a sag, or voltage rises, that is called as swells, or a complete loss of voltage, that is interruption. Now here three concepts that we need to learn, that is what voltage drop, that is in in the word of power quality that we can say that is voltage sag. If the voltage rises to a normal value, then we can say that there is voltage swell. And many times what is going to happen, so sinusoidal waveform, uh, that is total complete loss of that sinusoidal waveform that is going to take place, that are called as the interruptions. So in either case, the impact on the voltage duration during the actual fault condition is the short duration voltage variations until the protective devices operate to clear the fault. So these are the short duration voltage variations. Now the interruption. An interruption occurs when supply voltage or load decreases to less than zero point 0.1 per unit for the period of time not exceeding 1 minute. So complete loss of what you can say supply voltage. So interruptions are measured by the duration, since the voltage magnitude is always less than 10% of nominal. The duration of an interruption due to the fault on the utility system is determined by the operating time of the utility protective devices. Some interruptions may be preceded by the voltage sag. When these interruptions are due to the faults on the source system, the voltage sag occurs between the time a fault initiative and a protective device operates. So this is what the three-phase RMS voltage for the momentary interruption due to the fault and subsequent recloser operation. So this is simply graph in between time and voltage. So here at 1 second you will get a complete loss of that waveform. So that is what one type of momentary interruption. Then we will see that is voltage sag. So sag, or that is called as the dip, is the decrease to between 0.1 to zero point 0.9 per unit in a RMS voltage or current at a power frequency for a duration from 0.5 cycle to 1 minute. So if you think about this diagram, so 0.05 to 0.10, that means for you will get a what you can say decrease in voltage between zero point 0.1 to zero point 0.9 per unit of RMS voltage and current. Then you can say that that is what the voltage sag. So if you see the diagram, second diagram, that is B diagram, so voltage sag caused by SLG fault, that means single line to ground fault. So RMS waveform of voltage sag event, and B is what the voltage sag waveform. So if you see the waveform from 0.05 to zero point 0.1, so you will get a change in the amplitude, that is called as the voltage sag. And then we are going to see this is what the temporary voltage sag caused by the motor starting. So at starting, if you are going to think about the induction motor, So or any motor if you are going to take, so at starting it will take a more current. So when it will take a more current, then there are chances, or there there are chances that voltage goes down. So that is called as the temporary voltage sag. So you can take any motor such as the induction motor or DC motor. At starting you will get a higher current. So if you are getting a more current, then ultimately that is going to hamper the voltage also. Now voltage swell. A swell is defined as an increase to between 1.1 to 1.8 per unit in RMS voltage or current at a power frequency for a duration from 0.5 cycle to 1 mm 1 minute. So again here voltage swell means what? Voltage increases. Now if you are going to think about the from 0.05 to 1.15, so you will get a voltage rise. So if the voltage rise from 1.1 to 1.8 per unit, so and for a short duration, then we can say that that is what the voltage swell, that voltage increases. This is what the diagram, if you are going to that is caused due to the SLG fault, that is single line to ground fault. Now here temporary now next thing that we are going to discuss here, that is long duration voltage variations. So long duration variations encompass root means square deviations at a power frequency for longer than 1 minute. Long duration variations can be either over voltages or under voltages. Over voltages and under voltages generally are not the result of the system faults, but are caused by load variations on the system and system switching operations. Now this is what the diagram. So in this diagram, if low frequency oscillatory transients caused by the ferro resonance of the unloaded transformer, so how the pattern that you are getting, so how the changes that you are getting for the long duration voltage variations if the ferro resonance condition of unloaded transformer is there. So this is what the diagram here. From this diagram you can come to know that yes, these are the long duration voltage variations. Now next thing that we are going to discuss, that is what the over voltages. Now when you will get that over voltages, and over voltage is an increase in the RMS AC voltage greater than 1/110% at the power frequency for a duration of longer than 1 minute, then causes, what are the causes of that over voltages? So switching of a large load, energizing a capacitor bank, and incorrect tap setting of the transformer. So in that case you will get the over voltages. So under voltages, when you will get the under voltages means whatever the nominal voltage is there, if the voltage is less than that nominal voltage, then we can say that that is under voltages. But if that is 90% less, then also we can say that that is under voltages. But if that duration is longer than 1 minute, then only it comes under the under voltages category. Under voltages are a result of switching events that are opposite of the events that causes the over voltages. Causes load switching, if you are going to switch the load, the capacitor bank switching off, if you are going to switching off the capacitor banks, and then also will get, and over voltage overloaded circuits can result in the under voltage also. Okay, so next part that we will discuss in next lecture. So thank you all. So we'll stop here.